Have you ever looked up and seen a bird just chilling on a power line, completely unfazed? It's a super common sight, right? But it begs the question, how on earth are they not getting zapped into a little puff of feathers? We're taught from a young age to stay far away from those high-voltage wires, yet these birds treat them like their own personal park benches. What's their secret? Is it some kind of bird superpower? Well, it's not magic. It's pure, fascinating physics. And today, we're going to break it all down. Stick around, because by the end of this video, you'll understand the science behind this everyday mystery, and you'll probably never look at a bird on a wire the same way again. First, let's talk about what electricity actually is. Think of it like water flowing through a pipe. Electricity is the flow of tiny particles called electrons through a material, which we call a conductor. This flow is called an electric current. For this current to flow, it needs a complete path, or what we call a circuit. And crucially, electricity always, and I mean always, wants to take the path of least resistance to get to the ground. It's lazy. It's looking for the easiest, most direct route home. This is a key piece of the puzzle. Now, let's bring our feathered friends back into the picture. When a bird lands on a single power line, its two little feet are perched on that one wire. Since both of its feet are on the same line, there's virtually no difference in electrical potential between them. Imagine the electricity is a river flowing past the bird's feet. The bird is so small, and its feet are so close together, that the electricity just doesn't see a reason to detour through the bird's body. The wire itself is an excellent conductor, usually made of copper or aluminum. It's designed specifically to let electricity flow with very little resistance. A bird's body, on the other hand, is not a great conductor. It's made of flesh and bone, which offers a lot more resistance. So the electricity has a choice. Does it continue on its super easy path along the wire, or does it take a difficult high-resistance detour up one of the bird's legs through its body and down the other leg only to end up right back where it started? For the electricity, that's a no-brainer. It overwhelmingly chooses to stay on the wire, the path of least resistance. A tiny, almost immeasurable amount of current might pass through the bird, but it's so minuscule that the bird doesn't even feel it. It's like a massive river encountering a tiny twig. The water just flows around it without any trouble. So, as long as the bird is only touching that one single wire, it's basically invisible to the powerful current flowing within it. So, if that's the case, why are power lines so dangerous for humans? The answer lies in the ground. When we're standing on the ground, or touching something that's connected to the ground like a metal ladder, we create a direct path for the electricity to travel to the earth. The ground is the ultimate destination for stray electrical current. If you were to touch a power line while standing on the ground, your body would suddenly become that path of least resistance. The electricity would surge from the wire, through your body, and into the ground, completing a massive circuit. And that's what causes a severe, and often fatal, electric shock. The difference in electrical potential between the high-voltage wire and the ground, which is at zero potential, is enormous. This huge difference is what drives the current through your body. The bird, sitting pretty on its single wire, isn't connected to the ground. It's not part of a completed circuit. It's essentially isolated within the high-voltage environment. But what happens if the bird gets a bit ambitious and stretches a wing or a leg? This is where things can get dangerous, even for our feathered friends. The real danger comes when a bird touches to things with different electrical potentials at the same time. Imagine a bird sitting on one wire, and it stretches its wing and touches an adjacent wire. These wires often carry different voltages, or one might be a neutral or ground wire. By touching both, the bird creates a bridge. Suddenly, the electricity has a new path to follow from the higher voltage wire, through the bird's body, to the lower voltage wire. The bird's body is no longer a difficult detour. It's now a direct shortcut. This completes the circuit, and a massive current flows through the bird, resulting in instant electrocution. This is why you often see power lines spaced far apart, especially the big ones on those huge metal towers. The spacing is a safety measure designed to prevent anything, including large birds with wide wingspans like eagles or hawks, from accidentally bridging the gap between wires. The same tragic outcome can happen if a bird touches a power line and a grounded object simultaneously. Think about the wooden or metal poles that hold up the wires. These poles are typically grounded. If a bird is sitting on a grounded part of the pole and then touches a live wire with its beak or wing, it has just completed a circuit to the ground. Zap! It's the same principle as a person touching a wire while standing on the ground. The bird becomes the conductor, and the result is fatal. This is sadly a common cause of death for larger birds, whose size makes it more likely for them to accidentally make this deadly connection. Utility companies are aware of this issue and often install bird-friendly designs, like protective coverings on wires near poles, or perches that encourage birds to land in safer spots. They're trying to engineer solutions to protect wildlife from our electrical infrastructure. It's a constant challenge to balance our need for power with the safety of the animals we share our environment with. So, to sum it all up, the reason a small bird can sit on a single power line without getting shocked is all about the path of least resistance and the lack of a complete circuit. Its body offers more resistance than the wire, so the electricity just bypasses it. The bird isn't grounded, so it doesn't provide a path for the electricity to escape to the earth. But this birdie invincibility only lasts as long as it minds its own business on that one single wire. The moment it creates a bridge between two wires of different potentials, or between a wire and a grounded object, the laws of physics are unforgiving. So next time you see a row of birds lined up on a power line, you'll know exactly why they're safe. They're not daredevils. They're just unwittingly following the fundamental rules of electricity. It's a perfect, everyday example of complex physics playing out right above our heads. Isn't that cool? It just goes to show that there's amazing science everywhere you look, even in the most ordinary of sights. I hope this has cleared up the mystery for you. It's a question I know a lot of people have wondered about. If you enjoyed learning about the science behind this, give this video a thumbs up and let me know in the comments what other everyday mysteries you'd like me to investigate. And of course, don't forget to subscribe and hit that notification bell so you don't miss our next deep dive into the fascinating world of science. Thanks so much for watching, and I'll see you in the next video.